All right, we're now going to talk about the anatomy of breathing. To understand mechanics of breathing, let's go to physics. Oh, physics. Everyone loves to remember all these different cool equations. So Boyle's law is that pressure varies inversely with volume. So if we have some type of a volume like this, and we increase the volume, when volume increased, pressure decreased. Conversely, when we take the same volume, when the pressure is equalized, and now we reduce its volume, the volume decreased, therefore pressure increased and went up. Why am I saying this? Well, this plays into part with how all these muscles of breathing work, such as the diaphragm muscle. The diaphragm arises from the vertebral body, then attaches all along the internal surface of the rib cage and costal cartilage to the front of the sternum, a part of the xiphoid process, and along the opposite side of the ribs back to the vertebral column. But this muscle, that's an inferior oblique view. But if we now take a look at a coronal anterior view, we see that this muscle forms this big dome shape along the top. And if we see this cross section from a superior view, the lungs attach to the top of this. And if we remember from the parietal and visceral pleura, those pleural membranes and the pleural fluid, it then provides this hydrostatic pressure attached to the diaphragm. So whatever the diaphragm does, the lungs are going to follow. So the lungs are innervated by this somatic nerve called the phrenic nerve. It arises from the C3, from C4, and C5 spinal nerve levels, courses down, and in addition to taking sensory innervation from the parietal pleura, mediastinal and diaphragmatic parietal pleura, it provides motor innervation to the diaphragm. And because it comes from C3 and 4 and 5, which is important, we'll remember C3, 4, and 5 keep the diaphragm alive. That's the levels that contribute to that phrenic nerve. So the functioning of the diaphragm muscle is like playing with the parachute in elementary school. Remember those fun times where you'd be standing there on one side of the parachute and then there's one class member on the other side and you're looking at each other as the parachute's way up in the air and you're smiling, and then the teacher says, "Pull!" and the parachute becomes tight, and then they say throw it back up in the air, and goes way, makes this big dome shape, and then you pull your arms down and it flattens out. Dome flattens. Dome flattens when you contract and pull your arms in. Well, the diaphragm muscle is the exact same way. There we have it in this nice dome shape, and then when the muscles contract on that central white tendon in the middle, the central tendon of the diaphragm, we inhale. Or the diaphragm shortens and you make the lungs above it bigger. When the volume gets bigger in the lungs, the pressure decreases, creates a suction, and we pull air in. And then the diaphragm relaxes and the lungs get smaller and it forces the air out. And then, so inhaling, exhaling, or contraction, relaxation, contraction, relaxation. And it functions similar to that parachute in school. So now the thoracic anatomy and Boyle's law. So in this illustration, in blue, we see the airways, trachea, bronchi, and then the circle represents an alveolus. Those gray circles on the outside are the ribs and intercostal spaces, and the diaphragm muscles labeled, and we see the lung. What happens as we look at is that the pressure in P alveolus is 0. That's the amount of atmospheric pressure in the alveolus. And the PB is the outside air pressure, and they're both 0. Now watch what happens when the diaphragm contracts. You see that? Diaphragm contracts. What happened to the volume of the lungs from here to here? Volume got bigger. When volume gets bigger in any type of a container, the pressure drops. So now pressure within the alveolar sacs is lower. It says here P alveolus is -1. That means that it's lower, the pressure within the alveolus, than the outside. And that results in this suction that brings air in. And as air moves in, it equalizes again. So now the alveolar air pressure is equal to the outside, so there's no more air movement. But then the diaphragm relaxes. And look what happened to the volume from the diaphragm after it contracts to relaxes. Look what happened to the volume from here to here of the alveoli and the lungs. It reduces. So now pressure is greater within the alveolus than in the outside atmosphere, which then results in pressure movement of air out, and that's what happens when we exhale. So inhaling is an active process. exhaling is a passive process. So some of the other muscles that contribute to changing this diaphragm, because one of the things I should show here is that the diaphragm, when it contracts, it is increasing the volume of the lungs in a superior-inferior axis. When the intercostal and serratus anterior muscles contract, that's increasing the volume of the lungs laterally by lifting the ribs up. And so the example is you see that bucket handle movement, moving it up. It's the same way as elevating the lateral shaft of the ribs. So our intercostal muscles and serratus anterior do that. Where the scalene and sternocleidomastoid muscles do is like a pump handle that we show here on the right, is the way of moving the sternum superiorly and anteriorly. So you increase the volume of the lungs in a superior but also an anterior fashion, like scalenes and your sternocleidomastoid.